This is like a, I don't know what this is. This is like a pop scrub. This is a shoelace. This is like, oh, those sponge that you use for like makeup or something like that.
Ini nih. Nah, kita buah kan? 5. Expensive fruit. Alah, tak tahu lah. Kiwi. Inside ada avocado. Alah. Bukan sangka dia tahu apple. Okay. Sayur No. Mana ni? Buah naga.
So, the game is over. Let's dive right into the neurology behind the Mystery Box Challenge. In this challenge, people are able to guess the items merely by touch without the need of their vision. Although some items were more difficult to identify, the brain still tries to conjure up an image of an item in response to what was felt through the touch. Many studies have shown that when a human brain is shown a picture of an object, the part of the brain responsible for the touch sensory is also stimulated. This is what they often called the mind's touch. So how did this happen? Do humans really possess the ability to see with their hands? Let's find out, shall we? So first thing first, it all started with the touch. And who did the touching? The hands and the fingers. And what's present on our hands and fingers? That's right, the skin. The skin is the largest sensory organ in the body, consisting mainly of mechanoreceptors. When the hands and fingers move around the items in the box and tracing them, infinitesimal indentations stimulate the receptors on the skin and activate the signals for the sensory nerve. These signals then move to the somatosensory cortex, where they are translated into touch perceptions that allow for visualization in the mind.
There are 4 types of mechanoreceptors we can find in the human body. The slowly adapting type 1 afferents, SA1, slowly adapting type 2 afferents, SA2, the rapidly afferents, RA, and the Pacinian afferents. Now, let's look into the SA1 deeper. The SA1 system is referred to as the tactile spatial system, and it receives inputs from specialized receptors known as Merkel complex. These afferents densely innervate the skin and have small punctate receptive fields. As the name suggests, adapt slowly to sustain indentations of the skin. Individual SA1 afferents are capable of discriminating between 2 points on the skin of distal finger pad that are spaced about 1 mm apart, which is the spatial limit of equity of the somatosensory system. Each SA1 afferent can be considered to be a single pixel of a spatial image that is conveyed to the cortex by a population of afferents that have similar receptive field properties. SA1 system is responsible for processing information about 2-dimensional form and texture. This system is analogous to the parvocellular system in the visual system, which is also slowly adapting and it carries visual form information. The inputs from the different sensory afferents are sorted into segregated parallel processing streams. At the receptor level, receptors are distributed over the entire body surface. By the time they reach the cortex, they are segregated and different cortical areas are specialized for processing information from particular sets of afferents. This is called as modality segregation.
There is a disorder where a person is unable to identify objects by touch or feel. It is called the tactile agnosia or the acerugnosis. This occurs when there is damage along the pathways involved in the primary sensory processing areas, the posterior parietal cortex or the occipitotemporal regions. It can be caused by strokes, tumors, dementia, hypoxia, head injury or other neurological disorders.